Okay folks, time to have a look at building a real state machine framework using delegates and closures and reflection. So this is scene 3 of the tutorial. We're now using Finite State Machine 2. If we have a look at that, we'll see that it inherits from state machine base. We'll just have a quick look at the state machine running, show you it runs the same way. So I'll run the game, I'll walk around, see our enemies are asleep, and we can wake them up by banging into them, and they will chase us and attack us, and everything works pretty much the same as it did previously. Okay, so let's have a look at how that enemy is being controlled. We'll just for a moment ignore state machine base. So first of all, we defined a clear set of states for the enemy: sleeping, following, attacking, being hit, and dying. We've then got a code in start, and what that does is basically cache a bunch of things about the enemy so we don't have to do any get components later. Then we move into the states. You can see I've arranged each of these states into a region, which means it's very nice because we can collapse them all down like this and very clearly see which state we're looking at. So if we look at sleeping first, when you're in the sleeping state, it goes into it's in a coroutine. It loops all the time it's in this state, and what it does is it returns a yield based on a random amount of time, so up to 8 seconds, and after that yield it will create a new Z above the character's head, 3 world units above the character's position, and it will orientate that to face the camera. So it does that as it enters sleeping, it goes into this, and then of course that coroutine continues to run. Then every frame in update we check whether the player is closer than the attack distance, and we're using squares here because a square root is a recursive operation and therefore pretty poor on performance. So if the player has come within the attack range of the enemy, we set them as a target. We choose kind of an angle that we want to attack them at so they don't just come at us head on, and then we move it into the following state. So as soon as that happens, actually, as soon as we set this current state, it's going to stop running that enter state, and there isn't an exit state here, but it would have called an exit state had we written one. And then the only other thing that happens is if we enter a trigger while sleeping, so someone comes close to us on the trigger, then we actually go and call the following version of onTriggerEnter. So we'll look at that in a minute. Okay, so enemy states following, let's open that one up. So as soon as we called that following up here, we would have called any start, but there's no enter state happening, so we didn't need to do anything. So in following update, what happens is we check if the target that we're currently following is dead, and if they are, we put the character back to sleep. The moment we execute this line, this sleeping coroutine begins again. We then work out how far away we are from our target, and again we're using squares to avoid the square root. So if we're further away than the sleep distance, we just put the enemy back to sleep again. Again, that code up there runs immediately. If we're close enough to attack, closer than the maximum effective range of the attack, and we're pointing roughly at the target, we move it into the attacking state. We'll look at that in a moment. And then finally, if we've got through that, what we're going to do is move the enemy towards the target, and there's a bit of code here to make sure the enemy is facing its movement direction before it actually moves. Then if something enters the trigger during the following phase, or as you'll remember, the sleeping phase also delegates to this, we first of all check, because we've got 2 colliders on each enemy, whether it's the enemy itself. That will only ever happen once in the game, but we don't want to hit ourselves. Then we check if it's the player, and if it's the player we always enter the following state and we always make the player our target. If it wasn't the player, we're going to go and get the enemy mood, if we can, out of the thing we hit. So if the thing we hit had an enemy move, it must be another enemy, so it's a rival. If that's not null, we take a random number and check whether it's greater than the mood divided by 100, which basically gives us the more angry an enemy is, the more likely they are to attack each other. And let's say it got there. What we do is we now set the target to be the other enemy, and we make sure it's in the following state. And that's really there because, of course, this might have been entered via sleeping. So an attack then. An attack doesn't need an update. Everything happens in the coroutine that's the enter state. So first of all, we set up the animation. Attack is the cached attack animation. So we enable it, we rewind it to the beginning, and we make it play with full weight. And then we start this function that will wait until it's 50% of the way through. There's 0.5 here, the ratio. And when that comes back, we will be halfway through the animation, so we check if the target is still alive and whether the target is still in range. And if it's alive and in range, we tell it to take some damage. And then we wait for the animation to finish, get to 100% or ratio of 1, and we stop the animation having any effect. And then we, based on whether the target is alive or dead, we either go back to the following state or the sleeping state. Just two more to look at. Being hit, incredibly easy. We play the hit animation, and then either we go to following or sleeping based on whether the target is dead. And dying, even simpler, we play the dying animation. And that's it. So that's how the actual state machine works for the enemy. As you can see, it's pretty clear, it's neatly arranged, it looks quite nice, and because of what we've done in state machine base, it's actually highly performant. So let's go and have a look at state machine base. So this is the meat of the article. It's a highly technical article if you've read through it. We're going to ignore just why I'm doing this up here. It's basically caching, but in the next part of the tutorial we'll be looking at why this is an extremely good idea. So the awake function is just doing that caching. Oh, here's a neat trick as well. We've written an awake function inside a base class. And if we want this awake function to be called, we mustn't write an awake function inside our derived Finite State Machine 2 class. Or if we do, we've got to make sure we call base.awake inside it. So sometimes it's neater not to worry about that. And what you do is you just have a virtual onAwake method that does do nothing, and you could override this in the derived class, and then you just call that method in here. So if we wanted an awake function in Finite State Machine 2, we'd override onAwake. Then what we've got here are a bunch of methods that don't do anything. So a coroutine that immediately exits, a void method that does nothing, and one that takes a collider that does nothing, and one that takes a collision that does nothing. And we're having these because if the state doesn't provide a function, for instance, for update, then we want it to do nothing, and so we'll pass it that. So here are the delegates, the meat of this whole state machine framework. We'll build upon this in future elements of the tutorial, but this basic fundamental never changes. So we have an action. An action is exactly this, a method that returns nothing and takes no parameters. We have one called doUpdate. We default it to do nothing. Down here we have an action. This is using the generic parameter of collider. So what that says, it's a function that returns nothing and takes one parameter, which is a collider. And we've got that for trigger enter, trigger stay, and trigger exit. Then for the collision ones, we've got this one here, an action that takes a collision. So that here, do nothing collision, is an example of one of those. It returns nothing and it takes a collision. So these are just definitions of delegates, pointers to functions that need to be formatted to have this signature. So an action, a void that takes no parameters, and so on and so forth. The final one down here, the other type of generic delegate, a func. And what happens with the generic parameters of a func is the last one is what it returns. So because these are coroutines, we have an IEnumerator as the return value of the coroutine, and that's just a function that does that. We don't need one for enter state because we never need to cache that. We're just going to call it immediately as we enter that state, but as you'll see later, that will change. So here's another bit of the magic. We want to be able to immediately do things when we update the current state, so we've declared it as a property. When we set the value of current state, we will call this configure current state method. So we don't need to actually call it manually. As soon as we do current state equals something, we'll call that method. So here is that method. What it does is, first of all, it says, have we got a cached exit state routine? And if we do, then we're going to start it. Then we're going to go and get, for the current state, all of our delegates that we've defined. So one for update, on GUI, late update, fixed update, on mouse up, down, enter, exit, drag and over, so on and so forth. And we're calling this function we've written here a generic method called configure delegate to do that. And we're going to have a look at that in a second. So down here we get the enter state. As you see, we're not caching that by getting a delegate for whatever the current state is underscore enter state. And then we're immediately starting that coroutine. So here it is then, configure delegate, kind of the important function. It's a generic method, so it's going to return t, and it's going to be configured with t. And what we need to say is where t is a class. And that's because down here, in a moment, we're going to need to cast the return value of create delegate to be the type that we return here. So if it's an action collision, we want this to be cast as an action collision, and that means it can't be a value type. So we have to put this clause in our generic method saying t must be a type of class. So first off, the meat of it, we're going to get the type of the current object. We're obviously normally calling this when we've got a derived class. In fact, this class is abstract, so you can't ever make an instance of state machine base. So we call get type. So even though we're calling that inside state machine base, it will get the real type of the derived object. Then we ask that object to get us one of its methods, which is called the name of the current state, an underscore, and the name of the parameter we passed in. So in this case here, let's have a look at one of these, on collision stay. So if we call this one, it's going to be looking for a method called whatever the current state is, so let's say sleeping underscore on collision stay. Then we pass some binding flags through to it to tell it what type of method. So we want a method that's part of the class. We want it to be public or private or protected. Non-public is both private and protected. And we want to make sure that it is actually a method for invoking a method directly. There's one other type of method you can get, which is the set method of a property. Normally wouldn't be an issue, but just for belt and braces, we're passing that invoke method. Then basically, if it had one, if method that's returned by this get method function, a method info structure, is not equal to null, we can go and ask delegates to go and create a delegate. This is a type of the delegate, so we pass that in T, so it's maybe an action collision. We want to close this delegate over the current class. So this is where, when we return this delegate, it will have a reference to the this pointer when we call into it. And then we pass in that method we returned, and we cast it to be the return type. If that method wasn't found, then we return the default value. So for instance, in the case of on collision stay, do nothing collision, which we looked at earlier on. So that's pretty much it. Then down here, we just use those delegates. So when this class has its update method called, we call do update. Late update, we call do late update. So on and so forth. We just pass them all on, delegate them to the delegates. And then we've got these couple of little helper functions that will wait for an animation by creating a coroutine that waits for an animation, basically. And we'll look at those more in detail in future episodes where we make them even more powerful. So that's it. There's a state machine framework there. If you've read the article, you'll have seen a lot of things around closures and delegates, and hopefully that will have explained it. But here it is in action. Hope you've enjoyed it. Thanks for the time.